Our next concept is polynomial division. I'm going to separate this into two videos. There's two different ways we can do this. I'm going to show you long division first, and so that's what this video is. So I'm just going to break down a couple things with division. So you're going to see a lot of problems like this where you have polynomials divided by different types of monomials, binomials, trinomials, different things like that. This one's pretty straightforward. It is a polynomial divided by a monomial. So this one can be pretty easy. Another way you might see that is like a fraction. And maybe it's easier for you to see it this way, but really all I'm going to do is divide each term by 3y squared. So if I were to rewrite that, it would look something like that. And so what I end up with is 12 divided by 3, which is 4. And I'm using my exponent properties. Y to the 5th divided by y squared is really y cubed. I subtract my exponents. Then I get 9 divided by 3, which is 3. I subtract my exponents there. It's really just a 1. Don't need to even add that there. And then my y squareds are going to cancel off in that term, and I just get minus 5. And so there's my answer. Okay, pretty straightforward. Just simple division with a monomial. But then we get into actual long division. And it gets a little trickier. And so I'm going to demonstrate a division problem just to help us remember long division. So if I were to take 2,888 and divide it by 8, what would that process look like? I'm going to take you step by step through that one and show you how that matches up with this. So I can take 6x squared plus 7x minus 20, and I'm going to divide that by 2x plus 5. And I can use long division just like I do with numbers. So first step, I check to see, does my divisor go into my first digit? Does 8 go into 2? No. So does 8 go into 28? How many times does 8 go into 28? 3 times. So I try to figure out how many times does that divisor go into that first term. I'm going to look at my first term of my divisor, 2x. How many times does 2x go into 6x squared? Well, for sure it's a 3. X times x is going to give me x squared. So I'm going to put a 3x there. Okay. Next, I multiply the number I put up top times my divisor and then put it underneath. So 3 times 8 was 24. I'm going to do the same thing over here. 3x times 2x gives me 6x squared. Notice how I'm lining up the like terms. 3x times 5 is 15x. Okay. Now back over here. What did we do with this? Well, we subtracted them. So I got 28 minus 24, and I got a 4. I'm going to do the same thing here. I'm going to subtract everything here. So I'm going to subtract a 6x squared, and I'm going to subtract a 15x. So I've got to change my signs on both parts. And those cancel out, and I get negative 8x over there. All right, next step, you bring down your next digit. Same over here. Right, bring down my next digit, then I do the same process. How many times does 8 go into 48? This one is 6. Right, and then I do the same thing. I multiply it out, subtract. Oh, I got to keep going. So I get 361. Same process over here. What times 2x is going to give me negative 8x? Well, negative 4. I multiply that, I get negative 8x minus 20. If I subtract that, it's really subtracting a negative, which is adding. So I just change my signs. And I'm left with a remainder of 0. My answer, my quotient, is 3x minus 4. So that's using polynomial long division to to find your quotient. Very similar to long division of numbers, same process. Just now we've got x's in it. Another example. I've got 2x cubed plus 7x squared plus 2x plus 9 divided by 2x plus 3. So I'm going to set that up the same way I just did. I'm going to write out my dividend. And put my divisor out on the outside. This one is 2x plus 3. Good. And so I'm going to start by saying what times 2x will give me 2x cubed. Well, the 2's are good. I don't have to multiply by anything with the coefficients. I need to multiply by x squared to get me my x cubed. So that gives me 2x cubed plus 3x squared. My next step is to subtract, so I'm going to change the sign of both. Those cancel out. I get 4x squared here. Bring down my next term. Okay. 2x goes into 4x squared. I need to get 2 times 2 to give me the 4, so I know it's going to be plus 2. And then x times what gives me x squared? X times x. Once I figure that out, then I multiply it out. I get 4x squared plus 6x. And then I'm going to subtract those. So those cancel out, and I get a negative 4x, and then I'm going to bring down my 9. Okay, 2x times what gives me negative 4x? Minus 2. So that gives me negative 4x, and then negative 2 times 3 gives me negative 6. I'm going to subtract those. I'm running out of room here. And change the signs. So I end up with 15. And 2x plus 3 is not going to go into 15. So what I've come up with is I have a remainder. I have a remainder of 15. How you can see that is you could see R 15. I have a quotient of x squared plus 2x minus 2 with a remainder of 15. Or my quotient could be x squared plus 2x minus 2, and then plus 15 over my divisor, which was 2x plus 3. So that's just my remainder over there in that fraction. Okay. All right. Last problem, last example. I've got x cubed minus 2x squared minus 4 is divided by x minus 3. So I'm going to write that out. And if you notice in your dividend, I'm missing a term there. I'm going to put that in there with a 0. So I'm going to put plus 0x. I didn't have an x term there. That'll help as I divide. Minus 4, and then on the outside, I'm putting my divisor. Okay. What times x is going to give me x cubed? Well, x squared. X squared times x is x cubed minus 3x squared. Subtract them, so really just change your signs. And I get x squared plus 0x. And I'm going to bring that down because that's my next term, even though technically I don't have it. What times x is going to give you x squared? Just x. X times x is x squared. X times a negative 3 is minus 3x. So that's where that 0x comes in because I have that term still. If I would have brought that 4 down, I would have had too many terms. So subtract, so I'm changing the sign of both, and I end up with 3x. Then I'm going to bring down my minus 4, and then I go back. X, what times x gives me 3x? So 3. And I get 3x minus 9 after I multiply that by my divisor. And then I need to subtract, so I'm changing both signs, and I end up with 5. So x minus 3 doesn't go into 5, so obviously I have a remainder again. I'm going to write it out as a fraction. So plus 5 over x minus 3. So kind of a process. but you can use polynomial long division to find the quotients of polynomials.